Hello everyone. Today we are going to see case study on temporal difference learning which is applied in design thinking in healthcare. So our case study is healthcare context using TD learning for adaptive diagnosis. So first of all we want to know about the design thinking. Design thinking is a framework for an innovation. So in this design thinking, it has five phases. The first phase is empathize, second phase is define, third phase is ideate, fourth phase is prototype, and fifth phase is testing. So first phase, empathy is what is the problem. It is analyzing what are the problems and the challenges which is humans are facing. And the second phase is define. The define is why it is an important. It is a research process and observing, understanding, and creating a point of view. So third phase is ideate. Ideate is how do we solve it, like a brainstorm ideas, good and bad. Do not stop at the observes. So fourth phase is prototype. Prototype is how do we create it. It is a start creating, experiment, fail cheap and fast. So, the future work of healthcare design, personalized care, technology integration, patient empowerment, and sustainable innovations. Design thinking will drive the development of more tailored healthcare solutions addressing individual patient needs and the preferences. Continuing the integration of advanced technologies like AI and IoT will reshape healthcare delivery, improving the efficiency and outcomes. Future healthcare designs will focus on empowering the patients, giving them more control over their health management and decision making. Design thinking will play a critical role in creating sustainable healthcare solutions that balance effectiveness, cost, and environmental impacts. So we are moving into a first phase. It is an empathy. It is the total understand about the stakeholders like doctor needs and the patient needs. For example, doctors often facing the time pressure leading to the reliance on heuristics in diagnosis. Patients are considered about receiving generic recommendations that do not account for their unique histories and symptoms. So, the doctor needs a tool that can provide accurate real time diagnostic support, a system that adapts to changing patient conditions over time, ensuring relevant recommendations, user friendly integration into existing workflow, avoiding distribution or additional conjunctive burdens. The patient needs are an AI system that considers their unique medical history and personal context, assurance of privacy and ethical data usage. So we are moving into a second phase. It is a defined phase, framing the problems. This problem definition guides the development of the TD learning powered tool by identifying the states, action, reward. The states are patient medical history, current symptoms, vitals, and test results. The actions are diagnostic suggestions or treatment recommendations. The rewards are improved patient outcomes, faster diagnosis, and fewer diagnostic errors. And the third phase, we are moving to the third phase. It is an ideate, generating the solutions. During ideation, the team proposed way TD learning can addresses the problem. A system where the AI agent learn from patient specific data over time, improving the diagnostic accuracy as it updates the predictions based on their outcomes. So TD learning to model long-term patient health trajectories, helping doctors make decisions that optimize both immediate and future health outcomes. So we are moving into the fourth phase. It is a prototype building the AI tool. A prototype diagnostic tool could features patient dashboards and TD learning algorithms, feedback loop. Patient dashboards display the current conditions and the historical data in a simple user-friendly interface. TD learning algorithms are it makes real-time diagnostic predictions and update it model based on doctor feedback and patient outcomes. Feedback loop is a doctor confirm or adjust AI recommendation, which the system used to refine its future predictions. Doctor inputs a patient's symptoms and the medical history. The tool suggests a potential diagnosis, example, phenomena and recommended tests. If the test confirms the diagnosis, the TD algorithm updates its learning to the strengthen the similar predictions in the future. So we are moving into the last phase. It is an testing. Testing is an iterating for success. The prototype is tested in a clinical setting with feedback from doctors and patients. Doctors, patients, iterations. It is based on these three. First, doctor assess where the tool improves their efficiency and diagnostic accuracy, and patients provide feedback on quality of care and trust in the system. Initial feedback might reveal the interface is too complex for a quick use in emergencies. Iteration simplify the dashboard and ensures that critical recommendations are easy to access. So, real time learning, TD learning allows the AI to adapt immediately based on new patient data, offering continuously improving the diagnostic supports. Long term optimization by predicting the impact of the decisions on future health outcomes. TD learning ensures treatments align with both immediate and future goals. Personalizations, the system trials its learning to individual patient histories, making it more accurate and trustworthy. So the conclusion of this case study is combining design thinking with temporal difference learning creates a powerful framework for solving complex problems in healthcare. By deeply understanding the needs of doctor and patients and iteratively refining the tools, this approaches ensures that AI enhance patient care in a meaningful and ethical way.